Welcome back. Let's talk about our second sorting algorithm, and it's called selection sort. Now, selection sort is, again, one of the simpler possible ways to sort a list. And the algorithm works by scanning a list of items for the smallest element, and then swapping that element for the one in the first position. Let me show you with this animation here. We started with the first item and then the second item. The red here signifies that it's the smallest item that it's seen, and the blue is scanning ahead to find the smallest item. So right now 8 is the smallest item, but we encounter 5, so 5 switches to the smallest item. We encounter 2, so 2 becomes the smallest item. We keep going, 6 is not smaller than 2, 9 isn't, 3 isn't, we encounter 1, 1 becomes the smallest item. We keep going, we find 0, so 0 becomes the smallest item, and we've just finished the list. So now we move 0 to the first index in our list. So we swap it out, and then we keep going back to the beginning, finding the smallest item through the list, which is 1, and then placing that in the second index. And we keep going like this until we find the smallest item, place it next in the list, next in the list, next in the list, until we have our list completely sorted. As you can see, with selection sort, we're still going to see a time complexity of O of n squared. If we look at the time complexity chart, we see that selection sort is not very fast, similar to bubble sort. We have those nested for loops, but uses a space complexity of O of 1. It doesn't really add any additional data besides the input. Now, using the animation that you just saw, can you implement your own selection sort? I'm going to leave this for you as an exercise, using what you know from the bubble sort and what you just saw for selection sort, how you can use that information to sort the list using this algorithm. And I'll show you the solution in the next video. Bye-bye.